Hello and welcome to the Intro to Unity workshop. My name is Brandon and I am the current Vice President of SGDA, and this is just going to be a basic tutorial and workshop for introducing you to the Unity game engine. Before we get into that, I wanted to talk about what a game engine is, and basically a game engine is a tool for making games faster. Unity, the engine we're going to be learning today, is currently taught in the ATEC Fundamentals here at UTD. And in Unity, you basically start with a blank slate. You don't get anything built for you. You have to build it all yourself, which is very powerful because you get to design every facet of your game. And it uses C Sharp, which is a great language for learning. There is also Unreal Engine, which is taught in some of the upper level ATEC courses. And in Unreal, you don't start with a blank slate. Most of the time, you'll start with a full FPS or third person game, and you'll extend the functionality of that to make all of your mechanics. And it uses visual coding and C++. There's also a lot of other game engines like Godot, GameMaker, Construct, but today we're going to go over Unity. So to start off, creating a new Unity project. You're going to need to have the Unity Hub, which if you just open a new tab and type in Unity Hub, it'll show up right here. Click this and go ahead and download the Unity Hub. And once you launch that, you'll get it right here. And this is the Unity Hub. All right, and before you can start working with the Unity Hub, most likely you'll have to log in, and you can just create a Unity account, and then you're going to have to activate a license, which the license is completely free. It's just a free personal license, and you can add it right here, but you will have to set this up initially. And once that is set up, you need to go to installs, and this is your actual Unity editors. Now, these versions come out almost every week, and the one I'm going to be demonstrating with today is 2021.3.3. And if you actually go to install, you won't see it here. You'll have to go to the archive, and download it from here. And this will just show you how many Unity versions there are. There are a lot. Go to 2021.x and scroll down to 3.3, and you can install the same version. However, this workshop and tutorial you can use any version about 2017 or newer. So it's not version specific, but this is just the one I'll be using. And then once you have that installed, it'll actually pop up with this menu, and this is where you can choose your different platforms, like whether you're building for mobile, for Android, iOS, whether you want Mac support or WebGL. And I don't recommend selecting all of these because they do take up a lot of storage space, but select the ones you need. With that out of the way, I'm going to show you how to create a new project. So back on the Projects tab, you can click New Project, and there's a couple templates you can choose from. For us, we're going to choose 2D, and I'm going to go ahead and cover some of the other ones. And just so you know, if you choose one of these and you want to add something like URP or HDRP on top later on, you can do that. So you're not stuck with whatever one you do. If you do 2D, you do get the 3D tools. If you get 3D, you can add the 2D tools back in. So it's very flexible. And just to mention what URP and HDRP is, I have a couple examples that I've personally worked on. These are two examples, and URP is basically designed for any platform from laptops to computers to mobile to VR to just about anything you could think of. And typically it uses a lot of baked lighting, which is what is shown in both of these. And this just means that the lighting is baked in. There's no real time. If you move an object around, you will not get shadows from that object. You can also use real-time lighting, but if you want to go very far with real-time, you have to use HDRP, which uses a lot of real-time lighting. You can get some really good results out of it. This is Telemancer from Game Lab at UTD a few semesters ago. And the downside of HDRP is it only runs on good PCs. Even a lot of laptops struggle to run this. But for our purposes, we're just going to use Core because the URP and HDRP only really change the aesthetic, the art, and the lighting. It does not change any of the mechanics or how you build games. So go ahead and create a new 2D application, give it a name, give it a location, and then it'll show up right here. You can open this up. And Unity, the first time you open it, it will take a few minutes. Mine opened a lot faster because I've opened this project before. All right, but this is the Unity editor. So first of all, right in the center, there is the scene view. And this is something you'll have to get very familiar with. I'll bring some hotkeys for moving around. You can move around by holding right click and panning. And you can also scroll in and out with the mouse wheel. Whenever you select on an object, you can also press F and that'll center the object in your scene. And you can press that multiple times to toggle it. All right, so this is the scene view. And this is basically everything that is in your world or like in your game. So it's all of your objects, everything. And then complementing that over on the far left side is the hierarchy. And this is where basically a list of all of the objects that exist in your scene. So let's say you had a very large scene with a lot of stuff over here, just everywhere. This will show you all of them in a giant list. And to create new objects, you do it over here in the hierarchy. You can right click, go to 2D object, sprites, and then you have a couple options. Square, circle, capsule. It's probably squares and circles are what you're mostly going to use. And then we can talk about bringing in art later. But go ahead and do 2D sprites square, and you'll see we now have a square. Now to move the square around, up in the top left of the scene, there's a couple different options you can use. There's the view tool, which just lets you move around the scene. The move tool, which lets you move the object around with these giant arrows. The rotate tool, which lets you rotate your object. And you can hit Control Z to undo anything. The scale tool to scale your object. Like let's say you wanted to make a floor. And there's also the rect tool, which allows you to just transform it like just like a rectangle. And these tools can all be accessed with Q, W, E, R, T. It's just the first five letters of your keyboard on the top left. So Q, W, E, R, T. So really quickly, you should probably get used to these tools. Go ahead and play around with it. Like press W, move it around, maybe scale it down. You can use Control D to duplicate it and then move it. And just kind of play around for a few minutes, get used to moving objects around, scaling them, putting them in different positions. And this already is very powerful. You can just start building out a level. Let's say you want a new object. You can right click, 2D object, sprites, circle, and you just move it over here. And already you're kind of having something that might resemble a level you might want to make. All right, so that is the hierarchy and the scene view. There's also the game view, which is hidden behind the scene view up here. You can click on that, and now this is what your player will see. Like whenever you build out the game and you let someone else play it, you'll see something like this. And this is dictated by this camera, so you can actually move it around and see this preview right here changing. It's like if we do that, it'll update over here. All right. And then in the top right, or just across the entire right, there is what's called the inspector. And this is basically a large detail panel that talks all about the object you have selected. So right now I have a camera selected, and you can see it has a transform, camera, and audio listener. If I click on one of the other objects, a transform and a sprite renderer. And a lot of objects, you can have many different components on them, but every single object will always have a transform. And what a transform does is it defines where in the world they are by position, rotation, and scale. So if you want, you can actually move the objects around by dragging the little letter right here. And you can see it's moving around just like you would over here. You can also type in values, and it just works just like that. The sprite render is specific to 2D games, at least primarily. And you can see it says sprite, and it has a sprite selected that's square. So if you want, you could hit this little, if you see the sprite, there's a little like target, like a bullseye logo right on the side of it. If you click on that, this will show you all the sprites in your game. And say you brought in some other art, you can now switch it out for the other art. Like you can make it whatever this is. It doesn't look great because it's scaled, but this is how you would switch out art. You can see there's also a lot of other options in here. We're not going to go over all of them because there are a lot of other components as well. And you can see at the bottom of this, there's actually something called add component. And if we click on this, we can type in anything or use this little menu and actually choose different components. So first of all, I'm going to click on the circle that I made and hit add component and type in RIGID. And this will pull up rigid body. We're in 2D, so I'm going to choose rigid body 2D and click on that. And what a rigid body is it adds physics to an object. So this object now has physics on it. And this will tie into how the game works. So if you hit the play button at the top, Unity will take a moment and you'll see it now has physics. Of course, it just kind of fell through our world, and that's because we don't have any colliders. But to go over this one more time before I move on, whenever you hit play mode, this is now running your game. And any physics or scripts or anything else you have set up will start running as soon as you click play. You can also pause, and this will like just freeze everything in its place. And that's just how play mode works. So it's a way of like simulating your game and seeing what your players would actually experience whenever they play your game. And so we can get this looking more interesting, let's go ahead and add colliders to these objects so they can actually interact with the rigid body. If I click on add component and type in circle, we can put a circle collider. And you can just barely see it, but there's actually a green circle around this object. If I disable the sprite render with this checkbox, you can see that a lot more clear. So now this sprite render has a collider on it. And let's go ahead and select both of our squares. You can select multiple objects at the same time. Add component, box collider, 2D. And you'll see now there's that green box around it as well. All right, and now if I hit run on the game, we now have physics objects that actually interact with each other. But just to go over this one more time, I have created a circle. I put it up here just because I wanted to. I gave it a rigid body 2D and a circle collider 2D. And then I also created two squares, and these both just have box collider 2Ds. These do not have rigid bodies because I don't want them to have physics. They're just acting as colliders. All right. Talk about the project view, which is down here at the bottom of the screen. And this contains all of your assets. And what assets are is there different art or like source files you would bring in from other programs, or they're your scripts, they're your materials. There's a lot of stuff that they can be. Basically anything that's not directly in your world, but might affect things in your world. Or maybe they'll like be applied to the inspector, to objects in your world. Okay, and if we go ahead and see, there's currently a scenes folder. And if I open this up, we have a sample scene. And that's what this is right here. We're currently working in a scene called sample scene. All right, and there's a couple other things I wanted to mention about transform before we move on actually, because I think these are really cool. So we have the position, we have these values in here. I already told you you can drag them like this. You can also type in values. You can also say like +1 and it'll actually do math for you. Or you could say divide it by 2 and it'll divide it by 2. So you can do a lot of really cool and interesting stuff with this. You can also click on the little 3 dots on the top right of a component and click reset. And that'll put it back to the default values. This is very useful whenever we get into scripting later on. All right, I'm going to leave my object up here though. And we can also change the color. So let's say I click on both these squares. There's this color right here. I can click this, and let's say I can make it like, I don't know, maybe like a brown. And now they're brown. We also have our game view currently has this blue background, and that's just the default. We can go to background. So on select the camera, and then over here, there's a component called camera. And we can see it's currently set to solid color, and we can choose that color. So we can make just about anything we want, anywhere we want it. And there we go. So maybe this looks a little more interesting. And you could set this up with a lot of our components, more objects. You can change the colors to however you want. And everything still works the exact same. The ball still falls down, it still rolls. It's great. Okay, and with the project view on the bottom, we can right click. So just right click down here in the assets view, and you can go to create, and we can create objects. We can make new folders just to help organize our assets. We can create scripts, which we'll get into later. We can create a new scene. We can create materials, and materials are mainly relevant for 3D objects, not really 2D objects. All right, so let's say I want to bring in my own asset. You can actually drag in a folder and drag a PNG or a JPEG or whatever other image type. And you can drag it directly into here, let go, and here it is. And if you want, you can even drag this into your world. You can see it's a little bit small right now. So whenever you click on this, you can say pixels per unit and maybe do something like 16 because this is more like pixel art. And right here, it kind of looks a little like blurry. Like the object looks really blurry. And pixel art typically should not look blurry. So on filter mode right here at the bottom, you can go points and hit apply. And now that looks a lot better. So just like that, you can bring in like a character or something else you might have on your computer. And I'm not going too in detail on how this works whenever you bring an object in, because this is not really an art lesson, but there is something called a sprite editor, and this is where you could go and you could actually like, adjust your pixels. You could split this into multiple different images. There's a lot of powerful sprite or image editing you can do in here. Not image editing, but image manipulation, if that makes sense. Um, but just like that, I was able to bring in a picture, and you can just drag it into your world, and there you go. You could even add a box collider 2D, make sure, and a rigid body. Hit play, and now your character will fall down, and the ball will hit him and slide over a little bit. All right, but that's how you would bring in your own art. You can just drag it over here directly. Maybe you could right click, create folder, and call this art, and put them in the art folder. Okay. And just so you know, there's this little asterisk. I don't know if you can see this. It's under sample scene. Basically, in the top left on your hierarchy, your scene name might have a little asterisk next to it, and that means that you have not saved. So go ahead and hit Control S, and now you've saved your scene. And that can be important if something crashes or if something else happens. Something else that's important that you may not realize initially. Let me go ahead and create a square. Let's move it up here. If I hit play, the square is right here, and then maybe I'm like pause and I want to edit some stuff. Like let's say I want to move the square over here. Whenever you exit play mode, it will move it back. None of your changes will save. This is true for like making changes over here. Like let's say you had a player with a bunch of values on him. If you change any of this, it will not. It will reset it after you end play mode, which can get very annoying if you don't realize that. Okay, so moving on, we have a couple things that can happen. You can click on objects, you can delete them if maybe your scene's getting too cluttered. And let's go ahead and talk about how to Uh, Sorry, I'm just cleaning up my scene a little bit. You can also press tab and switch between these. So if you just really quickly want to type in 0, 0, -10 to move your camera back, or whatever else. So now we just have a simple character and a block. And in just a moment here, we're going to get into scripting, like how to start writing code in Unity. Okay, before we do that though, over here on Edit, so on the top, there's a lot of menus up here. And some of these are the same menus we've worked with before, like 2D object, sprite, square, like creating objects. So you can see game object, all of these tools are the exact same as these tools. Same thing with component, except you have to have an object selected. You can add components directly through here. And file and edit are two very important categories that have a lot of things that will be very useful to you. Say you go to file, you can create a new scene. And this is where like you make a 3D scene or a 2D scene. Like say you want your main menu in your game to be two separate scenes, and you can switch between them. You can do that right here. There's also build settings, which we'll get into later, and this is basically how you build out your game, so you can send like an exe file to someone else. But right now, under Edit, there's two things we want to talk about, being project settings and preferences. First of all, in project settings, this is basically a very, very massive list of, well, your project settings. I don't really think there's a better way to state that. It's like you have like your product name, your version, which is very specific stuff. There's a lot of specifics in here for like rendering and optimization, stuff like quality, like shadows. It's not really relevant for 2D, but just know that this exists and that there's a lot in here you might want to reference later. For us right now, go to Edit and Preferences. And most likely you will have to do this as well. And under here, most of this you'll never use or you won't use very often, but under external tools, so that's edit preferences, external tools, your external script editor, if you've never used Unity before, is most likely set to open by file extension. And whenever you have it set like this, it can be very difficult to work with code. By default, Unity comes with Microsoft Visual Studio 2019, and you may have to install this separately, which if you ever need to do that, you can just search in Visual Studio Community and you go do exactly 2019. You can download it directly through here, Community. This is 2022, but I don't think it'll make that big of a difference. There's also, you can use Visual Studio Code, which is like a very lightweight editor, or I personally like to use Writer, which is a very in-depth and thorough editor. And if you don't really like to code or you're not really sure what to do Visual Studio Code because it's very simple, it's very lightweight, and it'll likely be very good. But whenever you switch to any of these other ones, like say Visual Studio 2019, just because that normally comes with the Unity editor, you should click Regenerate Project Files. And if you don't click this, sometimes you will not get error checking or other important things like that. And error checking is so useful. So just know that you can switch your code editor right here, and you need to hit Regenerate Project Files. And I only recommend using Writer, Visual Studio, or Visual Studio Code. I don't really recommend anything else. All right, but I'm going to leave it on 2019 for now. Click Regenerate and close Preferences. Now, after that's done, you can go ahead and right-click, Create C# script. So let's right-click, Create C# script. Let's go ahead and name this Player. And now, this is how you know whether or not your the external tool actually works. Whenever you double-click this, oh, Unity's going to load. Whenever you double-click this file, it should open the editor you have selected. And typically this will take like a minute or two to open, and that's perfectly all right. But this is C sharp. So I'm going to teach you the very, very basics of C sharp and how you can do different things very simply, even if you have no idea how to code. All right. And you can see stuff's getting colored in here. Like we have blue, green. We have comments, which are denoted by two slashes. And this is code that does not run. This is just like personal notes. All right. So to start off, I'm going to explain what some of the default functions are. My Visual Studio is still loading. Okay, it just finished. So by default, it starts with a start function and an update function. And what this does is start is called before the first frame to update. And basically that means whenever you click play, this anything that's in any logic that is inside of the start function immediately runs. And also just for clarity, you can hold down control and use the mouse wheel and make your code bigger or smaller. So I can make it really big just so you can see exactly what I'm doing if you're on like a phone or a tablet or something else. Okay, so start is called on the first frame update, and I can go ahead and type in print, give it a string, and say start. Print is a default Unity function that will print something to the console, which the console for me is right here. Most likely, the console is hidden behind the project just like this for you. You can actually drag it and put it anywhere you want. And the way this works is through Windows. You can actually go Window, Layouts, and there's different layouts. Like I know a couple artists that really like this layout because they can see a lot more of like their art or whatever they're working on. Window, Layouts, Default will bring you back to this. And this is most likely what you started with. And you can drag this over. You can grab the line right here and actually move it around. Unity is very flexible and customizable. And I just want to go over that. But back to code. So I have a new function. It says start, and I'm just printing a mess or a string called start. And these quotation marks just mean this is not code. This is just text. So go ahead and do this as well. And then back in Unity, we have our script right here. You can actually see it says a little bit of our code. And if we hit play, nothing happens. Nothing shows up on our console. And so the way code works in Unity is this code is in the project view, not in our scene. It's not in our world yet. So we actually have to drag it onto our world. And I'm specifically going to drag it onto our character that we imported. And your character can be a square or it can be the circle from earlier. It does not matter. Just make sure you have something that can represent like what a character might be. So now I dragged player onto the character, and you can see down here at the bottom, we now have player in parentheses script. And you can click on these to minimize them. So now you can just see player in parentheses script. If you want to as well, you can also click add component and type in player, and here's the script that we made. So there's multiple ways of doing this. You can also just drag it directly onto here. And if you ever get like, if you've added it twice or something else, right click and click remove component. But once that's done, we have one copy of the player as a component on an object that's in our hierarchy, that's in our scene. So if I click play now, you'll see we get a message down here called start. And that just works. So we know that this code is running on the first frame up or right before the first frame update. So it only runs once. And there it is. Okay. I hope everyone was able to follow along with that. If you ever need to, just go back in the video or pause or do whatever else you need to. Um, but yes, I'm going to start moving a little bit faster just because I don't want this video to be like hours long. So in our player, we have print. We can also use debug.log start. This does the exact same thing. It's just personal preference whether you like to use print or debug.log. They are the exact same method. And then an update, let's say we want to do debug.log update. So these two functions, print and debug.log, are the exact same. So I have void start. These brackets denote what's inside of this function. And then I have lines of code that I'm just printing out text. So now if I hit play, you can see we have start and update is being called thousands of times. Because if I click on the stats up here in the top right of our game view, you can see how many FPS I'm running at. I'm running at like 800, 900 FPS, which is pretty crazy, but there's nothing in our world, so that makes sense. And you can see update is continuously running. And if you don't get this kind of view, it's because collapse is not checked. You can check collapse and it'll just give you a number instead of spamming your console, basically. Okay. There's a couple other functions that we should go over, being void awake. And just so you know, I'm just pressing enter and typing in new lines. Void on enable. So awake, on enable, start, and I'm just putting these brackets and pressing enter, and these are curly brackets. So it's typically in the top right of your keyboard, and you have to hold shift to type it in, but I just want to make that clear. There's also void on disable, and I'm going to add comments on these just so you all can understand what these actually do. Awake is called before start. So this is the exact same as start, but it's called before it. I'm actually going to say any start method is called. And what you do in awake is you typically want to assign references. And then we have on enable. On enable is called when the object is enabled, which that should be pretty self-explanatory. On disable is called when the object is disabled. And I mean, I think these both are pretty self-explanatory, but the uses may not be self-explanatory. What you would typically do is you would assign connections and then unassigned connections. And that may not make sense if you're not familiar with coding, but this may be useful to refer back to like later on whenever we get into more advanced coding. But for now, I'm just going to use debug.log. Remember, you can use print as well. And just type in the name of the function so we can actually see what these do. So we have awake and on enable. Okay, so that's awake, on enable, on disable, start, update. And I'm actually going to comment out update just because it sends messages way too often. So if I minimize that, I'll just show it one last time, just if any of you were following along with that. If I click play, we can see we have awake and then on enable and then start. And if I actually click on our character, and you can disable objects through the top left checkbox right here. So if I disable it, on disable is called. And if I enable it, on enable is called. Notice that start and awake are not called again. Only on enable and on disable are called. Okay? So that's when all of the functions are called. And yeah. So now we're going to get into actual coding, because this has just been basically what functions are available and when are they called. You can also create your own functions. It's like say void my function. And this will not be called unless you call it, like say my function. And now it's being called every update loop. But by default, this will never be called. And depending on what IDE you're using, it might say like this has 0 methods, or like it's never used, or it might give you what's called IntelliSense, which is just telling you what your code is actually doing. Okay. Um, so now I want to get into actually making a player, like a player we can actually move around and we can start to control and make an actual game. Because so far, we don't have a game. We just have a player that falls and sits on the ground. Whenever we type in our keyboard or do anything else, nothing actually happens. So to start, in our code, we're going to go ahead and do a couple things. First of all, we want our, um, so on our player, we have these different components, right? We have a sprite renderer, a box collider 2D, a rigid body 2D, and a player script. I want to get access to our rigid body 2D so we can actually control the physics of our object. So in here, I'm going to say rigid body 2D. And you can see as I start typing, I'm actually getting like autofill. And if you are not getting that autofill, or even it's writing code for me, if you're not getting that autofill, make sure it's going to reload scripts. Go to Edit, Preferences, and make sure you click Regenerate Project Files. This is the only way you will get um, your actual like autofill to work. Okay, so if you're not getting that, just make sure you go here and click this. That's Edit, Preferences, External Tools, Regenerate, and make sure you actually have one selected. Okay, so now we have rigid body RB, and remember in awake we assign references. So I'm going to go ahead and say RB equals get component rigid body 2D. And what this means is we're basically storing a variable of type rigid body 2D, and it's named RB. You can name it anything else if you'd rather. I just like to have it RB so it's simple. And I'm saying RB equals get component. And what this is doing, this is actually calling GameObject.getComponent. But we can simply just write get component. And what that means is a game object. So it finds this object, it finds this object right here, and it's searching all of the components. It finds transform, sprite renderer, box color 2D, rigid body 2D. So I'm saying specifically of type rigid body 2D. It will find that and assign it right here. So now if we want, we could say debug.log RB. And this is RB with no quotation marks because I'm actually referencing other code. If I do quotation marks, it would just be the text RB. It's no longer referencing the object. Okay, so now if I debug this, you can see it says character in parentheses Unity engine.rigidbody2D. And let's say this was on an object that did not have rigidbody2D, so I'm going to remove that temporarily. It now says null. And null just means it could not find the reference. That component did not exist. And I'm just going to add it back. And if you ever want to reorder these, you can right click, move up, move down. Okay? So now we have a rigid body 2D, and our script can access that rigid body. So now we can actually start to call logic on this. So down here in our update, and this is called once per frame. So this is called a lot, very, very, very often. So in here, I'm going to go ahead and start getting player input. So player input. And the way player input works is I'm actually just going to show it and then explain how it's actually getting this first. So we can say var horizontal equals input dot get axis raw quotation marks horizontal. and that's horizontal with a capital H. This name is very important. All right, and now we have horizontal. And let me just go ahead and debug.log this horizontal, just to show you what this actually does. But it's just written exactly like this. And var just means any variable. You can also type in float, because this is a float. Var is just a simple way of saying any type of variable. You can actually see my things, Visual Studio is telling me what type it is. All right, so if I minimize this and hit play, we're now getting a lot of zeros. And if I press D, we get 1. And if we press A, we get -1. Also with the arrow keys, I can press left and get -1 and right and get 1. So we can now get our position. And we can use that to start moving our player. There's different ways of moving the player. Because I'm using a rigid body, I want to move it through the rigid body though. But let's say you didn't have a rigid body, you could say transform.translate or transform.position, and it actually sets this equal to like a position. But for our purposes, we want to grab the rigid body. So rb.velocity equals, and what do we want this to be equal to? Well, we need a left and a right. So velocity is happening both on this red arrow and the green arrow. So we want to go ahead and say we want to only affect the left arrow. But we can't just say .x equals. We have to say equals new vector2 horizontal rb.velocity.y. And the reason I'm doing this is so we still have gravity. If I set this to 0, we'd constantly be overriding our y velocity, which would basically disable gravity. So I just want to do rb.velocity.y. And this horizontal is not exactly accurate because it's just -1 and 1. So if I actually close this and hit play, you can see we start moving left and right. So if I hold left, I go all the way left. If I hold right, I go right. And that just works already. Okay, so just to show you one more time, I just have var horizontal equals input.getAccessRaw horizontal. And we'll go over what this means in a moment, but not yet. And I'm setting rb.velocity to new vector2 with horizontal and just reuse the y velocity it already had. Okay, and now let's say we want to have a speed. So if I scroll up to the top, I can say public float speed equals 5. So just public float speed equals 5. And then down here, I can say horizontal times speed. So that's just public float speed equals 5. And the reason I say public at the beginning is now over here, I can see the speed value. So we can actually edit this inside of our inspector because it's public. Okay, and I'm multiplying the horizontal times the speed. So now if I hit play, we move really fast. And if I lower this value down, we move really slow. And if I make it really high, we move really fast. All right, so that is our speed. Okay, so moving on from this, we have rigid by velocity. We're applying a horizontal velocity and drb.velocity.y. We also want a way to be able to jump because currently we can only move left and right? Because all we're doing is left and right. So we need some way to, like whenever we press space or the up arrow or something, we jump. So if I go over here, I can say var jump equals input dot get key code dot space, and I'm actually very specifically going to say get key down. And what get key down means is whenever you press that button down. So key is for like keyboard, keys on your keyboard. So I'm saying whenever the player is pressing a key down on their keyboard, specifically the space key. That's all this means. We get a jump value. And this jump value is a Boolean. So I can say if jump and put brackets. And I'm going to say rb.velocity.y equals, well, let's make a value for this because I don't know, maybe it's 10. Maybe that doesn't work. And you can see it's actually complaining about rb.velocity. So remember, we have to say rb.velocity equals new vector 2 rb.velocity.x, comma 10. So we're just doing the exact same thing as up here. And we're setting the x, or I'm sorry, we're keeping x and we're setting y to a higher value. But let's go ahead and make this a float as well. Public float jump height equals 10. So public float jump height equals 10, and put this over here. And now back over in Unity, I can click play, and I can press the spacebar, and we go flying. And 10 is clearly way too high, so maybe I do a value of 3. Oh, that's way too low, maybe a value of 5. And now we can press the arrow keys, move around, and press space and jump up. And now we have a playable game. This all works. Let's say we want to start building out our level a little bit. Maybe we need some of this over here. And all I'm doing is I'm doing Control D and then moving it around, pressing R and scaling it. If you remember all those hotkeys from earlier. And we have a little game where we can move our character around. Oh, remember, I changed the value while we were in play mode, so it did not save. So I have to exit play mode, then change this down, and then play again, and now it's saved. So I can walk over here, jump up, and everything works. You can actually see I can kind of like start to flip over, and that's not what we want. We do not want the player to be able to flip over like this. Or maybe you do, I don't know. But for my purposes, I would like the player to stay standing up. So if we open up our rigid body 2D, we can go to constraints and say freeze rotation Z. And what this will do is it'll stop it from rotating on the Z. So now if I hit play, I can no longer do that. I can now move around and everything works. You'll notice whenever I move left and right, my sprite is staying only facing to the right. So maybe that looks a little bad. So we could focus on that next. Because we basically have a playable game at the moment. We can move around, we can jump. We can actually jump while in the air as well. If you notice, if you just press spacebar a bunch of times, you can just kind of like fly. So maybe we want to fix that as well. So I'm going to first fix the sprite. So the sprite actually looks over to the left whenever you're walking left, and looks over to the right when walking right. And then I'm going to make a ground check, so you can only jump whenever you're on the ground. Okay, so first of all, we want a reference to our sprite renderer. And you'll notice that there's actually this flip value, and I can just press X and it'll flip it. So I just want access to that. So in our player script, I'm going to say sprite renderer, and oh, render is not something you should use. Sprite. And And then in here, I'm just going to say sprite equals get component sprite renderer. So this is the exact same way the rigid body works, just with a sprite renderer. And then down here, I can say sprite, let me go ahead and say if horizontal is greater than 0. And what this means is this is facing right, or I guess more accurately, it's moving right. Sprite dot flip x equals false, because we want to face right. And we can say else if horizontal is less than 0. Well, now we are moving left. So sprite dot flip x equals true. And this is what's called an if statement. So basically, if this condition is true, horizontal is greater than 0, or if it's not true, so else, including if this is true, then we do this. Okay, so now this should just work. If I back out of here, maybe press F, zoom out a little bit. I walk right, I'm facing right. I walk left, I'm facing left. So now we have a much more alive character who's actually like moving around. His art's changing whenever you go around. Perfect. There's also this little scale slider if you want to look closer at your game. Okay, so now we want to check ground. And the way we check ground is we can basically check to see if there's any collider near the bottom of the player. So to do this, I'm going to scroll down to the update loop and say physics 2D dot circle overlap circle. I'm just going to get transform dot position and then 0.1f. And this may not be very clear what this is doing at first, but basically I'm taking the position of the object, so which is right here in the center of his face, and getting that position. So transform dot position, and maybe we'll say minus, or let's do plus vector 2 dot down. It wants vector 3 dot down. Okay. That's fine, because transform dot position is technically a three-dimensional array, even though we're in 2D mode. So transform dot position plus vector 3 dot down, and then at a radius of 0.1f. And just so you know, anytime you have a decimal in Unity, you have to have an f at the end of the decimal. And that just means it's a float. So just keep that in mind. If you ever need to write decimals, make sure you have an f. And if you don't have an f, it'll actually show up as an error. Okay? So now we have this overlap circle. And we can say var grounded equals this. And if jump and grounded. So if we press the jump button and we are grounded, then we do this. So now if I actually run our game, I can't jump while in the air anymore. But I can only not jump whenever I'm on the ground. So if I'm spamming spacebar, I can actually jump in the air. Okay, so now we have physics checks, we have a fully working player controller, and everything works. I hope this has all made sense so far. If you want, I can clean up this code and leave it on screen so you can pause just to see what's actually all happening. Let's see. There. So this that's on screen right now is everything you need to make a very basic 2D platformer player. It's not that many lines of code. It's only like 40 lines of code, and most of these are just spaces. But yeah, you can go ahead and pause, copy all this down if you don't have it, or double check, see if something's wrong on your end. And from this point on, we're going to go ahead and start getting into 3D. Okay, so our 2D platformer controller is done. Let's go ahead and go File, New Scene. So File, New Scene, and click Basic 3D. Go ahead and click Create. And whenever you load into the scene, make sure you click this little 2D button up in the top right, and it'll switch you into 3D. This lets you toggle between 2D and 3D if you ever want to have like a 2.5D game or something like that. But there we go. Go ahead and hit Control S, go into scenes, and let's just call this 3D. And basically that just saved our scene. So if Unity crashes or something else happens, we have our scene saved on here. It's always good to do that before doing anything else. Okay, so before anything else, navigation in 3D is a little bit more complicated than it is in 2D. Here is everything you need to know. Basically, you can hold Alt and use left click and drag to orbit around the scene. You can hold Alt and right click drag to zoom in and out. You can use the middle mouse and drag around to pan. You can scroll with the middle mouse wheel, and that'll zoom in. And my favorite way of moving around is holding down right click and using it to like look around, kind of like you're in a first person game or something. And while doing this, you can press WASD and actually move around the scene, kind of like you're piloting a drone or something. And this may take a little bit of getting used to. You can also hold shift and go faster, or use the mouse wheel and change how sensitive it is. But go ahead and play around with this. I'm going to leave this on screen for a little bit, just so you can get used to it, and so you can, if you forget or need to refer back to this, it's just right here. Okay? So let's get into 3D objects. Starting off, I'm going to hit right click, 3D object, plane. And something weird with Unity is it likes to create objects in weird positions. Like this is 5.75, 3.3, negative 2.4. Go ahead and click on the first one, 0, tab, 0, tab, 0. And that just zeroes it out. You can also click the three dots and click reset, and that'll do the same thing. Now, you will see a 3D object has a very different set of components than a 2D object. We have a mesh filter, a mesh renderer, and a mesh collider. Basically, the filter is for what object Unity should render the object as. Like what are the vertices, what are the triangles, that kind of stuff. The mesh renderer defines materials, lighting, and that kind of stuff. And the collider is for physics objects. Okay? We can go ahead and also right click 3D object cube, and you'll see we have a nice cube. Make sure you get used to these controls. I will be using them a lot more often now, especially that we're in 3D. It will take some getting used to. Just take some time, get used to the controls. Remember moving around objects, Q, W, E, R, scaling it up, rotating it around, everything like that. Pressing F to focus an object. It'll take some getting used to, but once you're there, it'll be so much faster. So let's say I have this cube, and it comes with a box collider instead of a mesh collider, which box colliders are more efficient than mesh colliders. And other than that, there's not that big of a difference. I'm going to go ahead and add a rigid body, just to show you how 3D rigid bodies work. I can hit play, and the cube falls down, just like you would expect. Okay? So this is very similar to 3D. Everything works almost the same way. It's just in 3D instead of 2D. And that can be very nice because, let me find a better place to put this. Just gonna leave it right here. It's very nice that Unity 2D and 3D work very similarly because that means you can start working on 2D and 3D games and it's not that confusing. All right, so I assume it's pretty easy to understand how to create 3D objects, especially coming from 2D. There's more objects. You have spheres, capsules, cylinders, planes, quads, all kinds of stuff. And I think we're just going to go ahead and start making a 3D player. I'm going to right click, create empty. And what an empty is, I'm going to name it player first of all. An empty just comes with a transform. There's nothing else on this object at all. I'm going to go ahead and zero its transforms out. And now we have a player. Of course, the player needs some visuals. It needs something to go with it. So I'm going to right click, 3D object, capsule, and I'm actually going to move this up one. And you'll notice this is actually parented underneath the player because I right clicked on player and clicked create object. If you right click down here and created a capsule, you'll see it's not underneath this. And there's actually this drop down. So what you can do is you can actually drag this object and put it underneath. And the reason you might want to do this is because if you select the player object that's on top of the capsule and move this around, you'll see all of the objects underneath it move with it. And that's very powerful. Okay, so we have a capsule. And the first thing I'm going to do might seem a little weird at first, but I'm going to remove the capsule collider. So right click, remove collider from the capsule. And the reason I'm going to do that is this object I'm going to rename to art. If you ever want to rename objects fast, you can you can click on the name up here. Sometimes you can double click it. I'm not actually sure on that, but you can press F2. So at the very top of your keyboard, F2, and you can name an object. So this is purely the art of my object. And maybe that's because you want to bring in an actual character model or something else later on. And then on the player itself, I'm going to add in a capsule collider. And you'll see it's actually in the ground. So I'm going to set its center to 1 unit up and its height to 2 units. That way it actually matches the capsule directly. Okay, so I just removed the capsule collider from here and I added it onto here. Okay, and now I'm also going to add a rigid body. So this will act as our player. Now before anything else, if I click play, this capsule, if I like move it, how do I get this to work? If you start rotating it, you'll see it actually topples over. And we don't really want our player to topple over, especially in a 3D game. So we're going to go into constraints, just like we did on 2D, and freeze X and Z. And what X and Z means is basically the rotation this way and the rotation this way. So now our player can only rotate this way, which is like which way he's looking. Okay. I'm going to leave this on the screen for a little longer. So now let's go ahead and create a script. I'm going to go add component, player, but this player right here is our 2D player. So I'm going to type player 3D and click on new script. And you can actually create a script. I'm going to make it capital. You can actually create a script right here from the add component menu. Create an add. And you'll see now you have a script on it. And it actually created a script over here. Let me go ahead and create a folder. So let's right click, create folder, scripts, and put both these scripts in a folder, just to keep it nice and organized. So now if I click on my player, I can double click on the script down here. You can also right click, edit script, or you can double click it down here. The Unity gives you a lot of ways to do the same thing, which is very nice. Okay, and let's open up the script. So programming a 2D player is relatively simple. A 3D player requires a little bit more work. But let's go ahead and get the same concepts down. I'm going to say public float move speed for the speed of the player moving around. And in fixed update, we're going to do the same thing. Var horizontal, oh my goodness, I cannot spell, equals input dot get axis raw horizontal. And I realized I didn't actually go over how this input function works. Right now, you're just blindly assuming that it does work. if I go over back into Unity and go edit project settings, remember this is something I said would be very important later on, input manager, and then there's this tiny little drop down right here called axes. And this is all of the different things you can call. So here's horizontal. And you can see it uses left, right, A, and D. There's also vertical. And you can see this also has support for controllers. So if you're ever wondering what all you can access, it's all right here. You can even go in here and actually change this. But I recommend against doing that unless you know what you're doing or you want to add new ones. Like say right click, you can duplicate this. It's like let's say right click, duplicate, and you can say like this one is now, I don't know, something like attack. And you can set different things on it. I'm going to delete that. Um, look into this further if you want. For now, the scope of this project, it's not necessary. So I'm going to get a horizontal input. I also want to get a vertical input. Okay. And you can see, so that's horizontal and vertical. And what that means is it's A and D and W and S. So WASD or the arrow keys, both work. And we're going to go ahead and get move direction. So var move direction equals horizontal times transform dot right plus vertical times transform dot forward. And let me go ahead and explain what these two things mean. So we have transform dot right, and what right is the if you actually click back over here and press W, you have these three arrows, right? Red, blue, and green. Blue is your forward. This is your forward vector. Red is your right vector, and green is your up vector. And if you actually rotate this around, you'll see it doesn't change, but that's because over here on the top left, you can switch to local, and now you'll see this is actually rotating with it. So you can see it can face in different directions. And that's just right up here, global and local. Global just means the world, right and forward and that kind of stuff. And local means, well, the local, like what this object is facing. Okay? So I'm just pulling that out right here through this. And I'm going to say var move equals move direction dot normalized. And what normalized does is it clamps the value. Like, oh, what's a good way to explain this? We're going to open up Paint to explain this because I don't know what else to do. Basically, let's say you have this circle, right? And right here in the middle is 0, 0. Whenever you press W, you get this vector pointing this way, right? And let's say it's at a value of 1, so it's at the top of the circle. And whenever you press right, you get this one. Right now, your total vector looks like this. It's actually extending out past the circle because it's going all the way from here. It's going all the way from here across and then all the way from here across. All that normalize does is it clamps it to, oh shoot. It clamps it to this right here. It clamps it to the circle. I know that might be a little bit confusing, but it's math and you don't need to worry about it too much. Just know you should normalize your two different vectors, and then we can multiply it by our move speed. Okay? So now we have a movement amount. Let's go ahead and get a reference to our a rigid body. So rigid body, RB, and we can say RB dot move position. And let's go ahead and say transform dot position plus move. And if I want to make this more clear, I can say var destination equals transform.position plus move, and we're moving to our destination, if that makes sense. So right now, if I close, or let me leave this open just for a moment so anyone who's catching up can catch up. So we have horizontal, vertical, and this is just grabbing input from our keyboard. We're taking a move direction, which takes our left and right and multiplies it by the right of our character, and our up and down and multiplies it by the forward of our character. We're normalizing that and multiplying it by speed, and then adding it to our current position and telling it to move to that position. I hope that all makes sense. Let's go ahead and hit play. And you will see we have a null reference error. Why do we have a null reference error? Oh, so we never called. Let me go ahead and write void awake and say RB equals get component rigid body. So remember that whenever we have a reference like this, we actually need to assign it an awake. And this right here, a lot of times errors can be very scary. Just know you can click on it and it'll tell you what line of code is giving you that error. So if I click on this little blue text down here, it'll tell me line 27, which means this rigid body right here. So RB was null. So now if I run this, we can press WASD, nothing happens because our move speed is 0. If I turn this up to like 4, oh my goodness. Okay, if I turn this up to like 0.1, we can see we're now moving around. And you can see it's kind of moving like A and D move it left and right on the screen, and W and S move it forward and backwards on the screen. And that's what we would expect, right? But it's very unintuitive to play from the camera being all the way back here. So I'm actually going to grab our main camera and drag it onto our player, and now it's underneath the player. And I'm also going to move it this way, move it up, and maybe rotate it down a little bit. So now if I click on our game view, it kind of looks like this. Maybe it needs to be even a little further like this. There we go. Now if I click play, because I parented it underneath, the camera will now, oh, our move speed is still 0.1. You'll see the camera's now moving with the player. All right, we almost have a third person character. Okay, I'm gonna go ahead and set 0.1 just so we have a default value. And back in our code, move position feels kind of rigid. It's not moving all that amazingly. But for now, we're gonna keep it just because it makes sense. And I suppose I should start talking about what these things actually do. There's different ways to move a rigid body. So I'm gonna go ahead and mention another one, rb.add_force, and we're gonna say move, and then force mode dot velocity change. So move position makes player move exactly to position. Using physics. Add force makes player basically get pushed in a direction. And we can also say rb.velocity equals, I'm going to say new vector3 move.x rb.velocity.y move.z. And this basically sets the velocity directly, sets the movement of the player directly. And right now, this one feels very snappy, but this only uses physics to check colliders. So I'm going to say checking colliders. This one, let's go ahead and just feel how this one feels. So if I comment these out and say rb.addForce, Oh my goodness. You can see it's kind of like very slidey movement, and it doesn't feel very good. And then this last one just sets the velocity directly. And this one will feel very snappy. We're probably gonna have to turn the speed up a little bit. But this feels very snappy, and it probably feels the best. Okay, so I want to talk about the benefits and downsides of each of these. Add force is amazing whenever you're not dealing with a player. Move position can have very unexpected results, and setting the velocity directly is probably what I would recommend for a player because it's directly controlling the velocity itself. Um, but yeah, there's different ways of moving a player, and you could work with any of these. But for now, getting a little off topic talking about the different ways to move a player, we need a way for the player to actually look around. Because currently, you can only look in one direction and move around. You can't use your mouse or anything else. So what we need to do is say var, say horizontal mouse equals input dot get axis raw mouse x. And if I actually debug.log this just to show you what it actually means. Oh, I'll leave that on screen for a moment. So this is horizontal mouse equals input.get axis raw mouse space x. So in Unity, you can actually see the value being displayed out down here. Oh my goodness. If you move your mouse around, you can actually see it's spewing out different values depending on how fast your mouse is moving. Okay, so basically it's just how much did the mouse move either left or right. So we can use this. We can say rb.move rotation because we want to rotate it. How do I want to explain this? Let's say var rotation offset equals trans. What do I want to do? New vector 3, 0, horizontal mouse, 0. So basically, I'm um I'm wanting to apply a rotation offset on Y. And the reason I want to do it on Y is if you actually look at these values, X is definitely not what we want. Y is what we want because we want the player to be able to look around. And Z is also definitely not what we want. So I'm just going to apply directly to Y. And I want, depending on which way you move the mouse, it affects the Y. So then I'm going to say rb.move rotation transform.rotation multiplied by quaternion.euler rotation offset. And I'm not going to explain quaternions. They are incredibly complicated. Um, yeah, I'm not going to get into it. Um, basically, it's these three values, and it's a mathematically efficient way to render rotation and not have weird issues. I don't think there's a better way to explain it. There's some great videos. If you're very interested, go search videos. If you're not interested, just copy this code. Know that to add two quaternions together, you have to multiply them. And yeah, you can learn more about it if you want. So now if I hit play, you can actually move your mouse and it starts moving. It's moving very slow though. So let's scroll up here, public float look speed. You could also call this mouse sensitivity, if that makes more sense. And just multiply it right here. I'm just multiplying on top of the offset. Okay, so look speed. Let's set look speed to a value of something like 10. And now I can look around. And you'll actually see it looks very choppy. Also I move too fast sometimes. This is rigidbody.move rotation, transform.rotation, multiplied by quaternion.Euler rotation offset. Like I said, if you want to learn more, go search it up. Um, it's way out of scope for this video. And we probably want relatively high values for this, so 5 and 10. And it looks choppy. I don't know how well this will show up in the video, but it's like very choppy movement. It's not smooth. And the reason that is because physics are only being executed at 50 frames per second. Our game was running at like 800, but we were only executing physics for 50 frames. And the way this works is actually void fixed update. I'm just going to debug.log fixed update. Let's actually paste this over here and just call this update. So fixed update runs when physics updates, whereas update just runs whenever the screen gets rendered again. So if I hit play, I don't know how well to be able to see this. Let me hit pause. You can see there's a lot of updates happening, and then one fixed update. And the fixed updates are pretty spread out. But just know fixed update is the only time whenever physics actually gets updated. And typically whenever you're working with stuff like this, remember that in move position and add force, we have to have really small values. The reason why that is because we were updating it way more often than it should have been updated. So let's go ahead and grab all of this actually and put it in our fixed update loop. Okay, so now this is all in a fixed update, and you'll see nothing actually changed with how our game plays. It's still choppy, I can still move around, but this code's only running like 10 times less often. And if we want it to look smooth, it's part of the rigid body. So go down here to interpolate and set interpolate to interpolate. And what this means is, what's a good way to explain this? Basically, let's say your object is moving like this, right? The way, what's a good way to show this off? Basically, these are your physics updates, right? Interpolate is just showing your object being, it's basically doing in-betweens if you come from an animation background. It's rendering stuff in between the actual physics checks. So it's smoothing out what your movement looks like on screen. Okay, that's the basic explanation, where this is a fixed update and the red is update. So if I set this to interpolate, hit play, we will now see this is super smooth. It's actually, the rotation is still a little bumpy, and we can fix that by, if we want, let's say this rotation, we don't even want to be physics based. We could totally put the rotation up here and just say transform.rotation equals transform.rotation plus or times quaternion dot this whole quaternion function right here. And an easier way to say this is like this. Transform.rotation times equals quaternion.Euler rotation offset. And then over here, we can just freeze our physics rotation. So now you'll see it's super smooth and it's way too sensitive. Set it to 1, and now look at that. That feels so much better. The reason being is the player looking around does not need to be physics-based. It actually doesn't even make sense for it to be physics-based. So I moved it over to here. Okay? I hope this hasn't been too scatterbrained and this has been easy to follow along, because I know I kind of jump over the place a little bit, but I hope you're learning a lot and this is making sense. We're going to do one last thing, which is make the player jump, and then we're going to talk a little bit about art and lighting and that kind of stuff. Oh, and how to build the game out. Okay, so let's add a jump to this character. Up at the top, I'm going to go ahead and add a public float jump height. If you remember from the 2D controller, something like this is very nice to have. And then in update, I want to say if in input.getKey down key code dot space. And the reason I'm doing this in update is because fixed update will not recognize your input all the time. So let's say whenever you press the spacebar, that's only recognized for one frame. Your fixed update is most likely not going to match that, so you want to do this up here. And then maybe we have a private bool called jump. We can say jump equals true. And then down here in the physics, we can say if we jump, well, we jump. rb.add force. And adding a force makes so much more sense for a jump, because setting the velocity means you mainly have to calculate gravity. So we can just add force. Um, new vector 3, 0, jump height, 0. And we want to do force mode dot velocity change. And this needs to be outside of the vector 3. Okay. So if we jump, we add the force, and then we need to make sure to set jump equal to false. So basically, whenever you press space, it sets jump to true, and then on the next physics update, it makes your character jump. I hope that makes sense. Yeah, okay. And we will have the same problem where the character is not grounded, but just to show it off first, let's set this to a value of like, I don't know, 2. Okay, 5. Now we have a player that can look around and he can jump. And this is already feeling great. The look speed's really high still. Remember, you have to change these values outside of play mode for them to actually save. But now we can look around, we can jump, and that all works great, except we can jump an infinite amount of times. So let's go ahead and go over here. And I'm going to talk about a layer mask. So public layer mask ground layer. And this will basically be what is the ground. So if I copy this, scroll down. Before I jump, I want to say bool grounded equals physics dot lay what is it? Check sphere. This will check inside of a sphere. Transform dot position, just to say 0.1f ground layer. And now we can say if we jump and we are grounded. So if we want to jump and we're grounded, yeah, okay. So if we jump and we're grounded, we want to add force and make the character jump. Okay. So now what is a ground layer? What is a layer mask? What's going on here? What is it? How does this all work? Basically, a layer mask is this right here. So in the top left of your inspector, there's something called layer. And we can actually click on this plane. This plane is the ground. And go layer, add layer. And on any layer you want, you can type in ground. And now we have a ground layer. Click on the plane, set layer to ground. So as you just click this, you can go add, you can add something in, and you can set it to that layer. And then on our player, we want to set ground layer to ground. And the reason we do this is because we don't want the player to check itself. So let's go ahead and go over here, and I'm going to introduce a new function to you, void onDrawGizmos. And what onDraw Gizmos does is, you know how the collider has like this green outline for like what the collider shape is? We're basically gonna create that. So I'm gonna say gizmos.draw wire sphere, and we're gonna say transform.position from a 0.1f. And this is just the exact same values as this right here. Then I'm also gonna say gizmos.color equals color.red, just to make it look pretty. Okay, back over in Unity, we will see there's now a nice little red sphere. Do you see this little red sphere right here? And this red sphere will show you what it's checking to see if it's ground. So currently, the player would also be checked as ground because this red sphere is colliding with both the player and the ground. So it would check both. And it'd be like, hey, the player's still grounded even though the player's like maybe up here. And the player's definitely not grounded up here. So we just want to make sure we're only checking the ground layer. Okay? I hope that makes sense. And now we can just see if we're grounded. And I'm actually gonna debug.log our grounded here so we can actually show off what that feels like, what that looks like. So if I hit play, we are grounded. And if I jump, oh, we are grounded. And if I jump, it's now false. And then true, false, true. So that works amazingly. And with this, we have a full first person or third person player we can move and walk around with and do basically everything with. Okay, so that is that. If any of you want, I can leave this on the screen for just a moment. Like you could pause the video and catch up with anything. What's a good way to make this more readable? I can even say jump equals input dot get key code dot space. And basically the difference between get key down and get key is key down is only whenever you press the key, and get key is just if the key is currently being pressed. So now you could just hold down space and keep jumping infinitely. Okay? Okay. So here's the entire script so far. And everything works as intended. We have a player we can jump around with. Now you might have noticed that you have a mouse. Your mouse is still visible, it's still moving around, and maybe you don't want that. Maybe you want your player to actually like be immersed in your game. And here we could actually go down and type in void start and say cursor dot lock state equals locked. And what this will do is it'll actually lock our cursor so we can't move it around while we're playing our game. And there we go. So our cursor is no longer visible, we can move around, everything works, and we can press escape to bring our cursor back. Okay? And that is a full player controller that we can move around and work with. Okay, now I'm going to start talking about a couple other things we can do with this. I'm going to go ahead and create a 3D object, a cube. Let's move it over here, move it up a little bit, maybe shrink it down. And I'm just going to right click, create C# script, and call this pickup. And if we actually open this script up, I'm going to choose one new function called void on trigger enter. And then simply I can just say destroy this, or actually destroy game object. And what this will do is whenever something enters this trigger, the object disappears. So if I minimize, click on this cube, add the pickup, and then notice that this is on trigger enter. So this collider actually needs to have this is trigger box checked. Now if I hit play, and if I walk into the trigger, it disappears. So this code immediately ran as soon as I entered the trigger. And you can get this to do other mechanics, like maybe it's a pickup, maybe it has some power-ups. You can do a lot of things. Something you might want to check is on trigger enter can have a collider other get entered right here. You can say if other dot um, dot has or get component player 3D. So let's actually just say var player equals this, and if player exists, then it destroys the game object. And maybe you could say player dot and call some functions on here. So let's say you had a public void on pickup. You could say player dot on pickup. So all this is I get a collider other, and say var player equals other dot get component player 3D. And if that player exists, call this function and then destroy itself. And this just prevents it from like other objects. Like say there's another physics object that fell onto this object. It wouldn't get picked up. It's checking to see if this is the player touching it. And down here we can just say debug.log pickup. And remember, this function is on the player that we created. So now if I hit run, if I walk into this, it picks it up and it says pickup. So you could do this like you could keep a score on here, like let's say public int score, and then down here you could say score plus plus. So now you're increasing your score each time you pick one of these up. One other thing that might be very important to know in Unity is called prefabs. This cube right here, let's say we like this idea of a pickup. What I could do is I could drag it down onto here, name it pickup, and now this object is blue, and that means it's called a prefab. And what a prefab is, if I duplicate this around a couple times, all of these objects are referring to this one object down here. So if I actually open up this object, or you could also press the arrow right here, and let's say you change the material. Let's give it a color. Right click, create material. Let's call this M pickup for material pickup. Let's make it red. If I drag this onto here, all of them are now red. So prefabs are amazing for stuff like this. Okay, and just so you know, that has to be done inside of here. Let's say if I change this right here, it'll only change that one, and it'll actually get this nice blue line, and that means you have to click overrides, apply all to update the rest. But let's go ahead and leave it on the red. Okay, and maybe we also want to create material m ground, and we can drag this onto the scene down here. Here, let's actually give it a color first, make it like brown. Now I can drag it, and you can see it update in real time, and you can let go on the ground, and now we have a nice brown ground. And maybe we want this to actually be like a dark gray. Okay, so now we have a player. We have some prefabs that each have a pickup trigger on it, and that all works. So if I click on the player, we can see we have a score value. If I hit play, we can walk around and we can pick these up. And you can see, oh, I now have a score of 3. And as I pick more of them up, 4, 5. So you can see my score is actually increasing down here. As one final thing, I want to introduce the canvas. So in your scene, if you right click, go to UI, canvas. And this canvas is a massive object that basically, whenever you're working on canvas, I recommend you go into the game view and you can right click UI text. And if you're doing text, you just have to click import this. And this will give you nice looking text. And let's say score dot dot 0. And maybe we do want to edit this in our scene view and just move it around like down here. And there's a whole bunch of fancy things you can do in UI. most of which I'm not going to go over just because, once again, this video is already long enough. But now we have a score value down here, and on our player, we could actually open this up. And this is where stuff gets a little bit weird. I'm going to say public text mesh pro UGUI. And you have to import text mesh pro as it is up here. Text. Let's actually say score text. Okay, so you have to import tm pro, and now you can have this. And I can scroll down here and say score text equals string score dot dot plus score. Okay, so I know I'm moving pretty fast here, but I assume you have the basic understanding of how to code now. So now we can start working a little faster. So we have an integer score, text mesh pro UGUI, which is score text, and we're setting that text to score plus score. And back over here on our player, we can actually see it has this now. We can click the bullseye and double click our text. So now if I hit play, whenever we pick these up, our score increases on the canvas. And that just works wonderfully. One final thing I'm going to mention is some stuff about art. Let's say if I open one of these cubes up, right click, light, point light. Maybe we move this up a little bit. And maybe we want this to be like a blue light. Maybe we want it underneath the object. You can now see all of these objects have a nice little point light under them. And maybe it actually makes sense for this light to be red. We can right click apply to prefab. And now we have a bunch of red point lights. So if I hit play, we can see these objects now have a nice little light under them. Okay, so there's a bunch of lights you can create. You can right click, create lights. There's effects for particle systems. There's audio for audio sources, videos. Audio is really cool because you can just drag audio directly into here, assign it, and then just have it start playing. You can have it loop. You can call this component through code the exact same way we do the rigid body. There's a lot of very powerful stuff on here. But to finish off this intro to Unity, I want to simply go over how to build out your game and how to finish a game. So go File, Build Settings, and this is the sample scene. We're now in a scene called 3D, so I'm actually going to right click, remove this, and click Add Open Scenes. So now it's set to here, and I'm on Windows, Mac, Linux. I'm just going to click this, and I'm going to click Build. Right click, create a new folder, call this Builds, open it up, select, and it'll start building. So if you miss some of that, it's just File, Build Settings, set up your scenes however you want. Whatever the top scene is, this is the one that will be loaded first, and then just choose your platform and click Build. And it just works as simple as that. Okay, I think this video has gone on long enough. I'm gonna go ahead and show you this demo. So just Unity demo, can double click it, and now it's in exe. And hey, look, here's your game. You have a game, you can walk around, you can look around, you can jump, you can pick up these objects and increase your score. And you could go off from here and make a really cool game. Okay, I'm gonna use Alt F4 to close the game because I don't actually have a way to close it. And you could just right click, or you could select all of this, right click, send to compress zip. And now you have a game you can send somewhere else. Okay. To finish it off, I did want to mention some other resources. We also do have this PowerPoint linked on SGDA, and this goes over some of the stuff I covered. And some final resources that I want to mention. These are some great YouTube channels and also just some other places that I would highly recommend for learning more. Brackeys is loved by a lot of people, and he's recently not been doing all that many videos, but his videos are all still relevant and they are great, especially for learning how to get or learning how to code and just do simple things. Okay. There's also Tarot Dev, AC Dev, which is Professor Adam Chandler here at UTD. And then some more advanced recommendations that I personally have is any of these. I highly recommend you check these channels out. They are amazing. And I hope you have a great time working with the Unity game engine. All right. So thank you for coming, or thank you for listening to the Intro to Unity workshop, and bye bye.